What is the smallest indivisible particle of any element? You will immediately answer saying it's an atom. But are you sure that atoms are not divisible further? If you remember, in the previous lessons, we have learnt about positive and negative charges. Have you ever wondered from where these charges arise? What exactly happens to any substance such that it gets charged? Well, the answer lies in our basic question. Yes, the answer lies in the question whether atoms are further divisible or not. Wait a second, what have charges got to do with the divisibility of atoms? Let us understand this concept in a very simple way. We know that the Dalton's atomic theory suggested about atoms being the indivisible particles of matter. However, in the year 1886, a German physicist named Eugen Goldstein carried out a few experiments which led to interesting results. He found new types of radiations in a gas discharge tube. What is a discharge tube, by the way? As we can see here, it's simply a glass tube connected to the electrodes. We know that the cathode is positively charged, while the charge on the anode is negative. The tube had a perforated metal disc placed nearly at the center, which acted as a cathode. The anode was placed at one end, as we can see here in the diagram. Now, when an extreme high electric potential was applied across the two electrodes in this setup, Goldstein found that lightly illuminating rays were emitted in the hollow space of the tube. He also found that the rays were moving to the opposite direction of the cathode. What does that imply? Yes, it implied that the rays have the same charge as that of the cathode because in nature, similar charges repel each other. This made him conclude that the rays are carrying a positive charge. He named these as the canal rays. They're also referred to as positive rays or anode rays. But now the question that arose with these observations was, where did these positively charged particles come inside the tube from? Many scientists put forth several hypotheses for explaining the concepts related to charges. However, the first convincing experimental evidence which was widely accepted was put forth by the British physicist J.J. Thomson. In the next lesson, let's understand what Thomson had to say in his hypothesis.